In this question, we're going to draw a Bohr model diagram for a neutral sodium atom. To do that, the first thing we need to know are how many electrons are in a neutral sodium atom. So to figure that out, we're going to go and look at our periodic table, and we're going to find sodium. So sodium is here. And we're going to look for the atomic number of sodium, which is this one in the top left, 11. So sodium has an atomic number of 11. That means sodium has 11 protons. Now, if we remember, in a neutral atom, the protons and electrons have to balance each other out so that the overall charge is 0. So if we've got 11 protons, we also have 11 electrons. So I know there are going to be 11 electrons in a neutral sodium atom. So now that I know I have 11 electrons, I'm ready to draw my diagram. So you can go ahead on a piece of paper and draw out our diagram. So we've got 11 electrons in total. The first energy level shell can only fit 2 electrons. So I'm going to draw them in here. So we've got 2 electrons there. The next shell can fit up to 8 electrons. So I'm going to add them and I'm going to count as I go. So I've got 1, 2 already, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I still haven't hit my total, which is supposed to be 11 electrons. So I've got 1 electron left that's going to go in the outermost shell. 11. So the rules for filling these are you fill the inside one first, and then you fill the next one, and then the next one. The first one can fit 2 electrons. The other shells can fit 8 electrons each. So how many electrons do I have in each shell? My inner shell has 2. That's energy level 1. The next shell from the inside, energy level 2, has 8 electrons in it. And the outer electron has just, the outer electron shell, energy level, has just 1 electron in it. So you can see that adds up to 11 in total. Okay, next question. How many valence electrons does a neutral sodium atom have? Valence means the outer shell. So valence means the outermost energy level. So for sodium, we can see from the diagram, I only have 1 electron in the outermost energy level. So I've got 1 valence electron. The last question asks me, what group is sodium in? So let's just go back and have a look at our periodic table. To find the group, we just need to go look at the column that sodium's in. We can see it's in group 1. So the reason it's asked us which group it's in is so that we can see this pattern forming, which is that sodium is in group 1 and it has 1 valence electron in its outer shell. In this question, we have a diagram that a student has drawn, a correct Bohr diagram for a neutral atom. So we need to use the diagram to answer the questions. The first question asks how many electrons are in this neutral atom. So this one's easy. We just need to literally count. So we've got 1, 2, 3, 4, 5, 6 electrons. So we can add that here. We've got 6 electrons in total. Next it asks, what element does this neutral atom belong to? So at this point we have to remember, since it's neutral, the number of electrons and the number of protons will be equal. So if we have 6 electrons, that means we must have 6 protons. And now we can head to our periodic table and look for something that has 6 protons. So that means it's going to have an atomic number of 6. So I'm looking along to find an atomic number of 6. Here it is. So carbon, that's our element with atomic number 6, meaning it has 6 protons. So I can select now, what element does this belong to? This is a carbon atom, since it's a neutral atom. Okay, next, how many electrons are in each energy level of this neutral atom? Okay, well, the first energy level is the one closest to the nucleus. So this is our first energy level, and we've got 1, 2 electrons in there. Oops, 2, there we go. Our second energy level is the one that's second closest to the nucleus. So that's the second one we can see here, and we've got 1, 2, 3, 4 electrons there. And then the third energy level isn't shown on the diagram because there are no electrons in it. So in this one, there are 0 electrons in the third energy level. The next question asks, how many valence electrons does this neutral atom have? So valence means outer energy level. So in the outermost energy level, here that's energy level 2, we have 1, 2, 3, 4 electrons. So we've got 4 valence electrons for this neutral atom. Lastly, it asks what group the element is in. So we can go check in the periodic table. And remember, the group is the column. So carbon is in group 14. So our group is group 14. But also, the valence electrons and the group are related. So if we have 4 valence electrons, we know it's going to be group 14. It's a little confusing that it's not 4. The reason why, if we go back to our periodic table, is that with this new modern numbering system we're using, it goes 1, 2, and then all of these transition metal elements in the middle are numbers 3 through 12. And then we go to 13 over here. So in our first few periods, we actually skip out numbers 3 through 12. We go straight from 2 with beryllium to group 13 with boron. So you can see it would have 1, 2, 3, 4 valence electrons, and it would be in group 14. On the other hand, beryllium is in group 2, and that would have 2 valence electrons. In this question, we're going to draw a Lewis dot diagram for a neutral nitrogen atom. So Lewis dot diagrams are very similar to Bohr diagrams, except they only show the outermost shell. So they only show the valence electrons. So first let's figure out for nitrogen how many valence electrons it would have. So let's go and look at our periodic table, and we want to find nitrogen to start with. And here's nitrogen over here. So there are 2 ways we can figure out the valence electrons. One way is just to count the total number of electrons. So we can see that our atomic number for nitrogen is 7. That means it has 7 protons. And since we're talking about a neutral atom, we know it's going to have 7 electrons as well to balance out those protons. So to figure out the valence electrons, we can just count up and say, well, if we have 7 total electrons, we know that the first energy level can fit 2. And so our second energy level can fit up to 8. We had 7 in total to start with, but 2 are already in the first energy level, so that's 5 left. So nitrogen would have 5 valence electrons. The other way to think of it is just to look at the group number. So nitrogen, if we look up, because the group is the column, nitrogen is group 15, and that's a shortcut for showing us nitrogen is going to have 5 valence electrons. So we can go ahead and draw our diagram now. We know it has 5 valence electrons, so we can fill them in. 1, 2, 3, 4, 5. And we know that that means that it's in group 15. In this question, we have a correct Lewis dot diagram shown. We're told it's for a neutral atom in period 3. And we're going to use the diagram to answer the questions. The first question asks, how many valence electrons does this neutral atom have? Remember, valence electrons means the outer shell, and a Lewis dot diagram only shows the outer shell. So here we can see we've got 1, 2 electrons in our outer shell, so 2 valence electrons. So we can fill that in here. Next it asks, what group is this element in? Well, as we now know, there's a pattern, which is that the valence electrons matches up with the group. So if we pop over to our periodic table, group 1 and group 2 have 1 and 2 valence electrons. And then we skip over to group 13, which has 3 valence electrons, group 14, which has 4 valence electrons, 15 with 5, 16 with 6, 17 with 7, and 18 with 8. So since this atom is an element with 2 valence electrons, we know it's going to be group 2. Okay, so at this point, we know that it's in group 2, and we've been told in the question that it's in period 3. So to figure out which element it is, we're going to have to go to our periodic table, and we're looking for something that's in group 2 and period 3. So we know it's going to be in this group and this period, and magnesium there is the element that's in both group 2 and period 3. So we know that magnesium is going to be our element. And so we can complete our Lewis dot diagram, because the thing missing here is that the element symbol should be in the middle of our diagram. So in this question, we're told we have a Bohr model diagram for a neutral oxygen atom. So this is a correct diagram over here for a neutral oxygen atom. Our first question asks us, according to the octet rule, when are atoms most stable? So this is just a definition, and the answer is that atoms are most stable when their valence shells are completely full, not partially full. So the goal for an atom to be most stable is to have the valence shell, that's the outermost shell that has electrons in it, to be completely full. Okay, so now let's have a think about our atom here. It asks us how many valence electrons does this neutral oxygen atom have? So we can go ahead and count them. We've got 1, 2, 3, 4, 5, 6. Remember, we're only counting the ones in the outer shell. Those 2 in the inner shell don't get counted because they're not valence electrons. So we've got 6 electrons in the outer shell, 6 valence electrons. Now it's asking how many electrons would this neutral oxygen atom need to gain or lose to become an ion? So when an atom becomes an ion, it's going to obey the octet rule. So it wants to end up with a full valence shell. So right now we have 6 electrons in our outer shell. And we know that for this shell, which is the second one, to be full, we would need 8 electrons in it. So we've got 6. If we were to add 2 more, 1 here and 1 here, we would have a full valence shell. So we would be obeying the octet rule. So ideally, this atom would gain 2 electrons. So we can answer that here. We would like to gain 2 electrons. Okay, next the question asks us, what would this ion's charge be? Okay, so let's think about this. So we know oxygen is, let's just check on a periodic table. Here's oxygen. Oxygen has an atomic number of 8. That means it has 8 protons. So let's just write that on our diagram here. We've got 8 protons in our oxygen atom. And now the number of electrons we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 electrons. And we should remember that protons have a positive charge, +1. Electrons have a negative charge, -1. So in a neutral atom, we would have 8 protons and 8 electrons. So 8 positive, 8 negative, they cancel each other out to give us 0. But here we have 2 extra electrons. Since electrons are negatively charged, that means we're going to have a charge of -2. And we can enter that with a negative sign here, -2. Finally, it asks us, what would the oxygen ion's symbol be? So the symbol for an ion is first the symbol for our element, which is going to be the letter O. If you don't know that, you can look in the periodic table to check. Then we add the charge afterwards, but strangely we put the number first and then we put the positive or negative sign. So oxygen would be oxygen 2 minus. So let's fill that out in our last box here. So to summarize here, the octet rule says the outer shell, the valence shell, needs to be completely stable. So here, when we needed to add 2 electrons to fill our outer shell, we were gaining 2 electrons, which are 2 negatively charged things, and so our final charge was -2. In this question, we have a neutral sodium atom shown. Again, we're asked, according to the octet rule, when are atoms most stable? The answer is always the same, when their valence shells are completely full. Okay, so in this question, how many valence electrons does this neutral sodium atom have? So the outer shell here is the 3rd energy level, and we actually only have 1 electron in there. So we've got 1 valence electron. Then it asks, how many electrons should this neutral sodium atom gain or lose to become an ion? Well, we know that according to the octet rule, we want the outer shell, the valence shell, to be completely full. So we already have 1 in there, so we could add 7 more electrons into our outer shell. 1, 2, 3, 4, 5, 6, 7. We could add 7 more electrons into our outer shell. And then we'd have 8 in total, which we know would be full. However, that's a lot of work adding 7 electrons. Alternatively, we can just remove the electron that's there in the outer shell. Then that 3rd energy level is now empty, and the 2nd energy level, which is this one here, that would become our outer shell because the next one would be empty. And you can see there we've got 8 electrons already, so that would be full. So when we've got less than 4 electrons in our valence shell, the easiest way to form the ion is to lose those electrons and remove that shell. So the energy level beneath that, which here is the 2nd one, will become our valence shell. So in this one, how many electrons would it need to gain or lose to become an ion? It would need to lose just 1 electron. Okay, now we're asked, what would the sodium ion's charge be? So in this question, we've lost 1 electron. Now let's just check on our periodic table here. Sodium, right here, has an atomic number of 11. That means it has 11 protons. So let's add that on our diagram. We've got 11 protons. And usually we have 11 electrons, but we just got rid of 1. So now we have 10 electrons and 11 protons. Remember, electrons are negative, a charge of -1, and protons are positive, a charge of +1. So here we have 1 extra proton compared with the number of electrons. So we're going to have a positive charge here of 1. So we can fill that in here. We don't need to type a positive sign because we know that the number 1 is +1, so we can just put 1 there. Okay, lastly, drawing the symbol for a sodium ion. So that starts by drawing the element symbol for sodium, which is Na. If you don't know that, you can go and check in the periodic table. Here it is, Na for sodium. And then we add the charge as a superscript. And the charge was +1. And when it's 1 for the charge, we actually don't write the number. We just do the positive sign to show there's 1 positive. So let's choose that one. Na+. So there's our sodium ion symbol. So again, this works exactly the same way. We're looking for a full valence shell. If we have less than 4 electrons in our valence shell, we're going to lose them to obey the octet rule and end up with a positive ion. On the other hand, in the first example, we had more than 4 electrons in our valence shell, so we gained electrons to fill that, and so we end up with a negative charge in that case. In this question, we're being asked to draw a Bohr model diagram for a fluorine ion that formed according to the octet rule. Okay, so to figure this out, first let's figure out how many electrons are in a fluorine atom. So let's go and check that. So we're going to find fluorine, and here's fluorine over here. Fluorine has atomic number 9, which means it has 9 protons in it. And so a fluorine atom would have 9 electrons. So let's go back and let's start by actually drawing a diagram of the atom, and then we can edit that diagram to form our diagram of our ion. So fluorine has 9 electrons, so we can start filling them out. We know that means 2 in the first shell. The first shell can only fit 2, and then after that, they can fit up to 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all 9 of our electrons have been placed. Okay, so according to the octet rule, our valence shell right now is the second energy level, and it has 7 electrons. To make it full, for the octet rule, to make it complete, we'd need to add 1 electron. So I'm going to draw that here. So we've added 1 electron to make that an ion that obeys the octet rule. So now how many electrons in total do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can answer that first question here. So now we can answer how many electrons in each energy level. So on the inside energy level, we have 1, 2 in total. That's energy level 1. And then energy level 2, we have 1, 2, 3, 4, 5, 6, 7, 8, since we wanted that one to be full. Energy level 3 doesn't have any electrons. That one's empty. So we've got 2, then we have 8, and 0. Okay, now it's asking us what group is fluorine in. Let's just pop back to our periodic table to check. Fluorine is in group 17. Group 17. How many electrons did the fluorine atom need to gain or lose? Well, we saw that it needed to gain 1 electron. Gain 1 electron. And what is the symbol for a fluorine ion? Well, we know it's going to be the symbol for fluorine, which is F. And then we're going to add the charge. Now it's gained 1 electron, and electrons are negatively charged. So it's gained a negative charge of 1. So it's going to be fluorine with a minus sign as the subscript. So we saw that fluorine needed to gain 1 electron in order to have a full outer shell. And so fluorine ended up with a -1 charge. And we'll actually end up seeing a pattern that things in group 16, such as oxygen, are going to need to gain 2 electrons to become stable with a full outer shell. So they're going to have a charge of -2. And things in group 15 are going to need to gain 3, and they're going to end up with a charge of -3. On the other hand, back here, things that are in group 1, we're going to find are going to end up with a charge of +1, since they're going to be losing a negatively charged electron. And things in group 2 are going to end up with a charge of +2, since they're going to be losing 2 negatively charged electrons. And the same for group 13. They're going to be losing 3 negatively charged electrons to end up with a +3 charge. So this is a shortcut we can use when we're trying to figure out the charge of our ions.